Welcome back. In the last two lessons, we built all 6 series clippers. The diode set in series with the load resistor right in the path of the current. When the diode turned on, current flowed through the resistor and the output followed the input. When it turned off, the path was open, the current was 0, and the output dropped to 0. Today we move the diode out of the series path and place it in parallel with the output. This is the parallel clipper. The circuit has a resistor R in series between the input source and the output node. The diode D sits between that output node and ground. The output voltage VO is measured across the diode, not across R like before. When the diode turns on, it acts like a short circuit across the output. That pulls VO down to 0. When it turns off, no current flows through the diode, and if the output is open-circuited, no current flows through R either, so VO equals VI. The clipping mechanism is reversed compared to the series clipper. In a series clipper, the diode being off caused 0 output. In a parallel clipper, the diode being on causes 0 output. But as we will see, the same diode orientation still clips the same half of the waveform. Variation 7. The positive parallel simple clipper. The diode is connected with its anode at the output node and its cathode at ground. When the input Vi is positive, the anode sees a positive voltage through R, while the cathode sits at 0. The diode is forward biased, so it turns on. As a short circuit, it forces VO to 0 volts. The current from Vi flows through R and through the diode to ground. The resistor R limits this current, so during the entire positive half cycle, the output is clamped at 0. Now when Vi goes negative, the anode sees a negative voltage. The cathode is at 0, which is higher than the anode. The diode is reverse biased, it turns off. With the diode off, no current flows through that branch, and with no load on the output, no current flows through R either, so there is no voltage drop across R, and VO equals VI. The negative half cycle passes through to the output. In short, positive half clipped to 0, negative half passes. The waveform confirms this. The dashed line is the input, a sine wave with amplitude Vm. For the positive portions, the diode is on and the output is held at 0. For the negative portions, the diode is off and the output follows the input. Written as a rule, when Vi is greater than 0, VO equals 0. When Vi is less than 0, VO equals Vi. The transition between on and off happens at Vi equals 0. Compare this with the positive series simple clipper from lesson 5. That circuit also clips the positive half and passes the negative half. The output waveform looks the same, but the internal mechanism is different. In the series version, the diode was off during clipping. In this parallel version, the diode is on during clipping. Variation 8. The negative parallel simple clipper. Reverse the diode. Now the cathode is at the output node and the anode is at ground. When Vi is positive, the cathode sees a positive voltage and the anode is at 0. The diode is reverse biased, so it turns off. No current through the diode, no current through R. VO equals Vi. The positive half cycle passes through. When Vi goes negative, the cathode sees a negative voltage, lower than the anode at 0. The diode is forward biased and turns on. It shorts the output to 0, so VO equals 0 during the entire negative half cycle. The result? Positive half passes, negative half clipped to 0. That is the naming rule. A negative clipper clips the negative half cycle. Put the two circuits side by side. Variation 7 clips the positive half and passes the negative half. Variation 8 clips the negative half and passes the positive half. The only difference is the diode orientation. Everything else is the same. One resistor in series, one diode in parallel with the output, and no DC bias source. These are simple parallel clippers because the clip-in level is 0 volts. Now compare parallel with series. A positive series clipper and a positive parallel clipper produce the same output waveform, both clipping the positive half to 0. But look at the diode during the clipping region. In the series clipper, the diode is off, it blocks. In the parallel clipper, the diode is on, it shunts. This makes the parallel clipper useful when you want a low impedance path to ground during clipping. In practice, the choice depends on the rest of the circuit. Let us recap. A parallel clipper puts the diode in parallel with the output. A series resistor sits between the source and the output node. When the diode is on, the output is shorted to 0. When the diode is off, the output equals the input. The positive parallel clipper clips the positive half. The negative parallel clipper clips the negative half. Both have a clip-in level of 0 volts, so they are simple clippers. One practical note. With a real silicon diode, the output is not exactly 0 when the diode conducts. It sits at about 0.7 volts for the positive clipper or minus 0.7 volts for the negative clipper. The clip-in line shifts from 0 by the forward voltage drop. Next, we add a DC bias source to the parallel clipper, just like we did for the series clipper in Lesson 6. That will move the clip-in level above or below 0. See you in the next lesson.